Hello,
Yeah,
hello, welcome all of you. I am Shubhranshu Bose, LGMU alumni, and completed masters from IIT Bangalore. Now I am working as a president in a manufacturing company, and especially I have worked in natural language processing in the manufacturing sector. In the different sector, we have applied this type of algorithm for analyzing the preventive maintenance, fire uh, resistance, and different type of engineering works have been analyzed in the NLP process, and it is very useful in the robotics also. Um, Here I am very much glad to present my work, my speech in these 2 hours. It is very short time to deliver this type of complex algorithm, but I'll try my best. Hope you all enjoy this class. First, I want to start this algorithm from scratch. What is NLP? First, natural language processing. NLP is a field of artificial intelligence in which computers analyze, understand, and derive meaning from human language in smart and useful way. By utilizing NLP, developers can organize and structure the knowledge to perform tasks such as automatic summarization, translation, named entity recognition, relationship extraction, sentiment analysis, speech recognition, topic segmentation. This is special work. Area of application, mainly social media analysis, banking and loan processing, insurance claim processing, customer relationship processing, security counter-terrorism, e-commerce, and computer social science. Last one is computer social science. Nowadays, it is very useful for computational social science. E-commerce, you all know the e-commerce, NLP is very much useful in e-commerce. Basically, where text is the data. Where text is the data, NLP is useful in that case. Computer cannot understand the text form. Computer only understand the digit, integer. That's why in this course, basically, all words, our work to convert all words to integer or coding. Code is formed by some alphabet and some integer. All words or main focus or main aim to word conversion from text to integer. It is our main focus. Now we want to understand. We want to develop a understandings on the text. What type of text are we use? Text, maybe English, maybe Bengali, maybe Urdu, maybe Tamil. Raw text has some spelling mistakes. Raw text has some noise. Raw text has some wrong punctuation. And raw text has some wrong parts of speech. Considering all this wrong, we want to develop a right sentence. How it is possible? Mainly, three, in brief, we are going 4 steps: in the lexical processing, to syntactic processing, to semantic processing, and then deep learning. Now we understand what is lexical processing. Lexical processing is the raw text, words, or sentence analysis. First, you will just convert the raw text into words. Example is I go to Calcutta. Number of words is 4. One, I, go, to, and Calcutta. First, we just convert this raw text into words, depending on the application needs, into sentences or paragraph as well. Then this word will be tokenized. It will be seen as one identity. One, just I is a token I, go is a token go, to and Calcutta is also token Calcutta. Then we go to the syntactic processing. What will we do? We just tagging their parts of speech. I, go is a verb, to is a preposition, Calcutta is a noun. Tagging these parts of speech. Then the semantic processing. Semantic processing is what kind of information will I get from this line? What kind of information? This is important. Then it is good. All information go to the model building process, that is deep learning. It form the machine learning, chatbot, sentiment analysis, so on, so on. Syntactic processing, the semantic processing is a lexical and syntactic processing don't suffice when it comes to building advanced NLP applications such as language translation, chatbot, etc. The machine, after the 2 steps given above, will still be incapable of actually underlying the meaning of the text. Such an incapability can be a problem for, say, a question answering system, as it may be unable to understand that PM and Prime Minister mean the same thing. Hence, when someone asks it question, who is the PM of India? It may not even be able to give an answer unless it has a separate database of PMs. This PM is identical with the Prime Minister. It must be understood by computer. It would not understand that the words PM and Prime Minister are the same by computer. You could store the answer separately for both the variants of PM, meaning PM and Prime Minister, but how many of this meaning are you going to store manually? At some point, your machine should be able to identify synonyms, antonyms, etc. on its own. Once you have the meaning of words obtained via semantic analysis, you can use it for a variety of applications. Machine translation, chatbots, many other applications require a complete understanding of text, right from lexical level to understand of syntax to that of meaning. Hence, in most of this application, lexical and semantic processing simply pre-processing layer of the overall process. In some simpler application, only lexical processing is enough as pre-processing part. So what is the brief? Brief is first, we get a sentence or paragraph, and this sentence to raw text to words, split into the words, depending on the application needs, then tagging the parts of speech, syntaxing, and all simplify the all complicated words into the root words. Example is a say observed, observing, and observe. The root word is, what is root word? Root word is observe. We need observe. There is three type of observe, observed, and observing. But we need only observe that because it is root word. It is processed in syntactic processing and then semantic processing. What is the usefulness of the semantic processing? Semantic processing mainly extract the actual meaning of the sentence. Actual information from sentence we extract through the semantic processing algorithm. Okay, then we go to next, text encoding. How can be done? What is text encoding? Data has been collected in many languages. However, in this course, you will be doing text analysis for English language. The text analysis techniques that works for English might not work for other language. Computers could handle numbers directly and store them on register, but they could not store the non-numeric character as is. The alphabet and special character were to be converted to a numerical value first before they could be stored. Hence, the concept of encoding came into existence. Briefly, what is encoding? Just conversion of text into the numeric value. Because since computer cannot understand the alphabets, computer only understand the numerics. All the non-numeric characters are encoded to a number using code. Also, the encoding techniques has had to be standardized so that different computer manufacturers would not use different encoding techniques. To summarize, there are two popular encoding standards: the ASCII, American Standard Code of Information Interchange, and Unicode UTF-8 and UTF-16. UTF-16 is more useful than UTF-8. We use mainly UTF-16. Sometimes we use UTF-8, who has bit 24 bits, and UTF-16 has a 8 bits, and ASCII system developed mainly, we use mainly in Python UTF-16 or UTF-8, but more useful is UTF-16. Then we understand the regular expression. What is regular expression? Regular expression, also called regex, are very powerful programming tools that are used for a variety of purposes, such as a feature extraction from text, string replacement, and string manipulation. Feature extraction is the main purpose of this regular expression or regex. For someone to become a master at text analysis, being proficient with regular expression is a must-have skill. Regular expression is a set of character or a pattern which is used for find some string in a given string. Let's say you want to extract all hashtags from a tweet. Hashtags from a tweet. We want to extract all hashtags from a tweet. A hashtag has a fixed pattern to it. A pound, that is pound, character followed by a string. Some example, hashtags are hashtag Mumbai, hashtag Bangalore, hashtag upgrade, hashtag something. You could easily achieve this task by providing this pattern and tweet that you want to extract the pattern from. In case of pattern is has string starting with hashtag. Another example is to extract piece of textual data. There is useful, the regular expression is useful in that case. When we need the all phone numbers, when we will need the all hashtags, tagged words, start tagged words, then a regular expression is very useful, because when we complaint analysis or review analysis of any company, that is an Apple phone or any banking system, SBI or ICICI, there is a different type of complaint registered. We want to see the how many words is hashtagged in the text in the document, in this document. Then we must use the regular expression where we can extract these words from this document. Then greedy versus non-greedy search. When you use a regular expression to match a string, rejects greedily tries to look for a longest pattern possible in the string. For example, when you specify the pattern AB and 25 to match the string A, BB, 3B, total 5B, A and then 5B, it will look for maximum number occurrence of B in case of 5. This is called greedy approach. By default, regular expression is greedy in nature. Why greedy? Because we want all information from this A, B, 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 B. That's why A, B, 2, 5. B starts from the second position and total covered the fifth position. This is a greedy approach. A non-greedy, what is non-greedy approach? The lazy approach, that is A, B only. There is no need of 2 and 5. Okay. Regular expression, one thing, this AB to 5 or AB, what is the information from this word? We know, we want to know what type of alphabet is used in these words. Just using regular expression algorithm, we can extract all specific features of any word in a large document. And then we want to know grouping. Sometimes you need to extract some patterns out of larger pattern. This can be done by using grouping. Suppose you have textual data with dates in it. You want to extract only the year from the dates. You can use the regular expression pattern with grouping to match dates, and then you can extract the component elements such as day, month, or year from the date. Then, okay, one thing we should know. Regular expression. Okay, later we know the codes of regular expression. First, okay. Word frequency and stop words. It is very important. What is stop word? Stop word is a D, A, and all of article, all preposition to, for. This is called stop word. Why it is stop word? Because we eliminate all these stop words from the main document, because we know we have no need to know no need to know the stop word information. We need only, I go to Calcutta, our main focus should be go and Calcutta. There is no need of to and I. We eat sweets. Our main focus is sweets and eat. One verb, one noun. There is no need of preposition, article. There is no need. That's why it's called stop word, and it should be eliminated from the document. It is done by the stop word algorithm system. Okay. Stop word algorithm system. How can I analyze the overall all stop word in a large document? There is a 10,000, 20,000, 30,000 stop word. How can I eliminate from this, from the document? It is, first, we want to know the frequency of word in a document. And in a large document contains several words. Say observe, say go, say come, say extinguish, bank, loan, customer, the different type of word. And in this, the large document where 2 lakhs or 3 lakhs word comprises 2 or 3 lakhs words, first we analyze the frequency of word. One word, how many times it is come in the document. First it is. It should be reminded. It should be known to all that stop word frequency is maximum all time. Maximum frequency means minimum is importance. Maximum frequency, the minimum is importance. That's why maximum frequency, those words with maximum frequency we can eliminate easily. First, there is a high, that is called the Giff law, linguistic statistical George Giff states the frequency of word is inversely proportional to the rank of the word. Where rank 1 is given the most frequent word, rank 2 is the second most frequent, and so on. This is called power law distribution. Giff law helps us from the basic intuition of the stop word. These are the words having highest frequency in the text are typically limited importance. Okay. Broadly, there are 3 kinds of words present in any text corpus. Highly frequent words called stop words, is and the, etc. Significant words which are typically more important to understand the text. Significant word. We need this significant word because we get different information from these words. Rarely occurring words which are again less important than significant word. Generally speaking, stop words are removed from the text for 2 reasons. They provide no useful information, especially in applications such as spam detector or search engine. Therefore, you are going to remove stop word from the spam dataset. Since the frequency of word is very high, removing stop word result in much smaller data as far as size of data is concerned. Reduced sized result in faster computation on text data. There's also the advantage of less number of features to deal if stop word is removed, because there is a more population of stop word in a document where 2 to 3 lakhs words are present. In this case, minimum 40 to 50,000 will be the stop word. Then if we eliminate this 40 to 50,000, then we only get the only 50,000, half of the word. And the features, features means the words, significant words. That is called features. Okay, features means the significant word. And then we should know the coding of the stop word. Okay, coding of the stop word. I share the stop word coding. Stop word. It is a library. We'll use the NLTK library, import free list and NLTK corpus, import stop words. Library is NLTK and import stop words. Okay, then define a function of plot word frequency. Just see the labels, element frequency distribution words. What's frequency? We name the file word frequency equal to frequency dist words, and count all the element. We find this type of see the. What is the number frequency? 1600. And what is the number? 700. This algorithm is running in a big document. Big document means 10,000, 5,000 and document, 5,000 words document, and 2 is near about 8,800. A 700. These all are stop word. Stop word. How to collect the stop word? This is from NLTK corpus, import stop words, print stop words dot words English. Just click and then I, me, myself, we, our, all are stop words. Let's remove this stop word from this simple one sample text is given. The great aim of education is not knowledge but action. Sample words, sample text dot split. First, before during the initiation of my speech, I told you that first work is to split the sentence into a words and then tokenize and then remove the stop word. Sample word, sample text dot split, and then the great aim of all are in a list. Remove stop words. Remove stop words, the sample words, words for words in simple words. If word not in stop word, dot words. And this is the important word, great aim, education, knowledge, action. What is the coding? Word for word in sample words. Sample words mean the great aim of education is not knowledge but action. This is for sample words, basically a sample text. And sample words is the great aim of education is not knowledge but action. Yes, all are sample words. The word for word in sample words, if word not in stop word, dot word English, which are not stop word, that was given great aim education knowledge. Then join words back to sentence, sample text, join sample words, great aim education knowledge action, extracting all the stop word, excluding all the stop word, removing stop word in the Genesis corpus, no stop. Now this is a matplotlib subplots is given. Okay, then we go again. the main speech. Hmm. Then we go to the what is tokenization. It's very important for the NLP system. In any of NLP algorithm, when we are analyzing the text, we need stopword removal and tokenization must. It is the basic pre-processing of the data. We already know that you are going to build a spam detector by the end of this module. The spam detector application, you are going to use word tokenization. That is, break the text into different words. That each word can be used as a feature to detect whether the given message is a spam or not. As you saw, there is a lot of noise in the data. Noise is in form of non-uniform cases, punctuation, spelling errors, grammar errors, etc., hashtag, star, dot. There are exactly the things that make it hard for anyone to work on text data. There is another thing to think about, how to extract features from the messages, so that they could be used to build a classifier. When you create any machine learning model such as a spam detector, you will need to feed in features related to each message that the machine learning algorithm can take in and build the model. But here in the spam detect data set, you only have two columns. One column contains the message and other contains the label related to the message, spam or ham. As you know, machine learning works on the numeric data, not text. Earlier, when you worked with the text columns, you either treated them as categorical variables or converted each categorical variable to numerical variable by either assigning numeric values to each category, or you created dummy variables. Here, you can do nothing of this. Since the message column is unique, it is not a categorical variable. If you treat it as a category, your model will fail miserably. You can try it as an exercise. To deal with this problem, you will extract features from message. From each message, you will extract each word by breaking each message into separate words of token. That is called tokenization. The technique is called tokenization, techniques that used to split the text. That words dot split, that is the code, used to split the text into smaller element. These elements can be character, words, sentences, or even paragraphs, depending on the application you are working on. We want to know, we should know the coding of the tokenization. How to coding of the tokenization. Yeah. It is visible? Is it visible?
Yes, yes, yes. Yes.
Okay. Tokenization. There is 3 types of tokenization. Word tokenization, sentence tokenization, tweet tokenization, custom tokenization using regular expression. Word tokenization means to split the sentence into a word and tokenize. Sentence tokenization means if sentence is very important, it gives some important information, then we can sentence tokenization also. What will we do? What will we do this in this case? We split the document into the sentence and tokenize the all sentence. Split the tweet as and tokenize the tweet. So on. What tokenization? As example, document equal. We consider one document at small line. At 9 o'clock, I visited him myself. It looks like religious mania. He will soon think that he himself is God. There is 2 sentences. One document comprises 2 sentences. Okay. And tokenize on the space using Python. First, split the document into the word. Print document dot split. At 9 o'clock, I visited him. Split. Tokenize using NLTK word tokenizer. Please remember, NLTK library is very useful, is a only useful library for tokenization for stop word. Okay, from NLTK dot tokenize import word tokenize, words equal to word hyphen tokenize document, print words, see the tokenization. Okay, there one thing should be observed here. The difference between split and tokenize list, split list and tokenize list. There a dot also, myself dot in split list, myself dot, and in tokenized list, dot is another token, dot get another token. During analyzing the stop word, we just eliminate the dot. Since tokenization has been done, NLTK word tokenizer not only break on the white space but also break contraction words such as he will into he and LL. On the other hand, it does not break o'clock and tears it as a separate token. Sentence token, then sentence tokenizer. Now, NLTK dot tokenize, import sent hyphen tokenize. Sentence is same. At 9 o'clock, I visited him myself. Just tokenize the sentence. Just see. At 9 o'clock, I visited him myself. One token. It looks like religious mantra. Then is another token. And then we see the tweet tokenize. Same message is same. And print what tokenize. Just to see. What tokenize breaks the emoji. This tweet tokenizer. Just see the list. Then we back. NLP tutorial. Okay. Then bag of words written. This is a very useful algorithm. very useful algorithm. When sum of words with linked with another words, then we can form the cluster of words, and that is called bag of words. Simple theory. If we want to extract the actual information of the document, we need to classify the words. We need to extract the relation between the words, neighbor words. We need to know the neighbor words. We need to extract the relation between the neighbor words. And those all words form a cluster, and that is called bag of words. In this section, you will learn how to represent text in a format that you can feed into machine learning algorithm. The most common and most popular approach is to create a bag of words representation of the text data that you have. Central idea is that any given piece of text, that is tweets, article, message, email, etc., can be represented by a list of all words and occur in it after removing the stop words, where the sentence of occurring does not matter. You can visualize it as a bag of all words that occur in it. You can create bags of representing each of the message in your training and test data. How do you go from this bag to building a spam classifier? It is a next level thought process. We don't go to this thought process in this workshop. It cannot be possible. I just explain the mainly fundamentals of the NLP method. Let's say the bags. Most of the spam messages contain words such as prize, lottery, etc. Most of the ham bags don't. Now, whenever you run into a new message, just the bag of words representation, does the bag of this message resemble that the message is you already know as a spam? Does it not resemble them? Based on the answer to the previous question, you can classify the message. In brief, we can say the bag of words, basically the features of the words. When we call a email is under the spam, then some words determine his spam identity or a ham identity. Those words, it may be called the features. Those words or features comprises in a one unit, and that is bag of words, one bag. And for ham also, it is another bag. It should be determined during pre-processing of NLP algorithm. And then go to stemming and lemmatization. What is stemming and what is lemmatization? Very interesting. It is very important also. In a data set, one data set, same word, same root word can be written in different form. That is warm, warmer, warmed, observe, observer, observing, observable. All are observed. Root word is observed. But it creates a 5, 6, 7 features. There is no need of 7 features. There is one feature observed. There is one feature worm. It should be analyzed. This is done by stemming and lemmatization. There is a thin line difference. In brief, it is stemming and lemmatization both are same, but it is a thin line difference. Rule-based technique. What is stemming first? What is stemming? Driver is racing in his boss car. Driver is racing in his boss car. Here drive, racing, race. We choose on the one root word or stem word. That is called stem word also. The driver here can be excluded, that's drive, and racing, ing can be. Really, racing is a RAC, race, DRIV, just drive. You might think that root form, that is called stemming. Yes, stemming, DRIV and RAC. You must think that root forms don't resemble the root words, drive and race. You don't have to worry about this because the stemmer will convert all variant of drive and racing to those root form only. It will convert drive, driving, etc. to drive, and race, RAC, race, racer, etc. to RAC. This gives a satisfactory result in most cases. Most cases it is satisfactory. But in most cases, not all cases. In some cases we use for this purpose the lemmatizer. The stemmer is a rule-based techniques where your ing will be excluded. That's rule-based, that is the rule. Hence, it is much faster than lemmatizer. And in case of lemmatizer, we extract the lemma of the sentence. And that is lemmatizer slower because of dictionary lookup, but gives better result than a stemmer. As a side, because lemmatizer follow the dictionary. There is no rule-based system. Stemming is a rule-based system, or lemmatizer follow the dictionary. Okay, this is the main reason. We need to know the coding of the lemmatization. Stemming. Just stemming. There's stemming code of stemming. Okay. See, NLP library same, and NLP stem.porter. Import porter stemmer. Text we can use very orderly, methodically, hooked with the land on each knee and something. That is text. And tokenize first. Tokenize it. Then stemmer equal to porter stemmer. What is it? Very VRY, and then stem is VRI, orderly LY, Y convert to I, and then same methodical ICL is excluded, method, the rule based. He looked, ED is excluded. Look with a hand on, this is stem. On this token, very porter stemmed, VRY, orderly, I. See the rule based, how much it is rule based, methodical, method, looked, look, ticking, tick, sonorous, sonor, he, flapped, flap. Almost 60-70% is right, or 30-40% is wrong. It is Also, for this reason, lemmatization is more better than this statement. And there is also 80% is right, 20% is something creating a problem. Okay. Then we go to TF-IDF representation. They're very important. TF-IDF. What is TF-IDF? Bag of word representing while effective is a very naive way of representing the text. It relies on just the word frequency of the words of a document. But don't you think word representation should not solely rely on word frequency? There is another way to present document in matrix format, which represent a word in a smarter way. It is called TF-IDF representation. It is the only that is often preferred by most data scientists. It is very important. In bag of words, we calculate the frequency of words basically. But in TF-IDF, frequency of words is important, but another term is also important. Frequency of sentence where any specific word is used. Say, example, I have given you 3 sentences where, 5 sentences where movie is found in 4 places, 4 sentences out of 5. And data, that word, data, is found in 7 times in 1 sentences out of 5. Which one is important? Movie or data? We can say movie is more important because movie is found. Movie can be important. It is actually, we must not say the movie is important only. No, it is a mathematical rule. There is some mathematical formulation. So, but we can say the movie may be important than the data because movie is found in 5 places, in 4 places, in 4 sentences out of 5, but data is found 7 times, but it is found in 1 sentences. 4 sentences, data is absent. That is called, that is analyzed by the TF-IDF representation. What is this? TF-IDF equal to TF multiplication IDF. Term frequency, TF equal to frequency of term T of document D by total terms in the document D. TF equal to frequency of term T of document D. In one document, how many T's come? By total number of document. IDF equal to log of total number of document by total number of document that have term T. That is TF-IDF value is more important to analyze, but to extract the important features in a document, in any document. Where bag of words fails, TF-IDF works. Higher the weight are assigned to terms that are present frequently in a document and which are rare among all documents. On the other hand, a low score is assigning to terms which are common across the all documents. Hello. Now, TF-IDF, we should know the code of the TF-IDF. Code of the TF-IDF. Okay, got it. This is the code of TF-IDF. NLTK library. Tokenizes what tokenize? Stop words, that is same. And basically on feature extraction, input TF-IDF vectorizer. Because the TF-IDF algorithm extract the features. That's why a scalar features extraction to dot text and TF-IDF vectorizer. Okay. And then document. Document is a gang of Hoshiarpur. Is a great movie. Hoshiarpur is a town in Bihar. The success of songs depends on the music. There is an so and so. First, stemmer, using stemmer, quota stemmer. First, actually split the word, then tokenize, then remove the stop word, then stemming. Okay, next, one by one. First, we get a document, raw text, and split this raw text into words, and then tokenize, and then remove the stop word, and then stemming or lemmatizing, and then TF-IDF treatment. Vectorizer, TF-IDF vectorizer. This is the TF-IDF model code. TF-IDF model equal to vectorizer.fit transfer, and there's a sparse matrix. This type of sparse. It is a form of matrix. 0, 0, 0, 11, 0, 5. It is a 5 is the position of a word, all word, and 0.34, 0.34, 0.25 is the TF-IDF value. This is the matrix form. Print the TF-IDF 2 array. It's a matrix form, the sparse matrix. It is called. And if we want to convert the data frame structure, column and row structure, that was 0, 1, 2, that is 3 sentences, and upper the column name is Bihar, depends, fun, gangs, great, movie, music, new, releasing. It's the features. Bihar at the 0 sentence, my first sentence is the TF-IDF number is a 0.34. Depends the word, the features. The 0.5 is the TF-IDF number for the second sentence. Gangs, 0.34 is the TF-IDF number for the first sentence. That's the TF-IDF value extraction. And that is important. And TF-IDF value, the more importance in the document. And let's create the TF-IDF model spam data set. We can use one data set where is already labeled spam or ham, message One column is message, another column is label. For big data set, same coding is used, vectorizer, TF-IDF vectorizer, and TF-IDF PD.data frame. We structure the data frame total. 0, 1, 2, 3, 4, that is the sentence, number of sentence, and data is a TF-IDF value, and upper column number 00077, that is all are the features of the word. Then we go to canonicalization. It's a very important. Canonicalization means to reduce a word its base form. Stemming and lemmaization were just specific instance of it. Stemming tries to reduce a word to its root form. Lemmatization tries to reduce a word to its lemma form. Root and the lemma are nothing but the base form of the inflected word. There are some cases that can't be handled either by stemming or non-lemmatization. You need another pre-processing method in order to stem or lemmatize the word effectively. Suppose you are working on words, the Agrawal, Agarwal, one spelled it, one is spelled Agarwal, another is spelled Agarwafl. Same information, Agrawal, but different spelling. How can I extract the actual information? Another is a disappearing and disappearing, double S. Same. Another is disappearing, 1P. In one case 2P, in one case double S. The three features is shown. How can I extract one features? Actually, what is it? Disappear, basically. How can it is? It is not possible by using stemming or lemmatizing. It's called only canonicalization is the only process to extract this type of fundamental problem. You still have the problem and the redundant tokens. On the other hand, lemmatization would not even work on these two words and will return the same words if it is applied, because it only works on correct dictionary spelling. To deal with the misspelling, you will need to canonicalize it by correcting and spelling the word. Then you can perform either stemming or lemmatization. You will learn the concept of edit distance, and which can then be used to build a spell corrector to rectify the spelling errors in the text that you are working with. Such as color in American English, COLOR. In British English, COLOUR, but both are same. But how can I? Coloring. Lemma and stemming both have no capability to extract this two form, coloring and coloring. Now we use in this case, we use the canonicalization, where spelling correction is done. To deal with different spelling that occurs due to different pronunciation, we'll learn the concept of phonetic hashing which will help you canonicalize different version of the same word to base word. Phonetic hashing. SoundX is our main tools to correct the spell. There is certain words which have different pronunciation in different language. As a result, they end up being spelled different. Example of such words include names, peoples, city names, names of dishes, etc. Take, for example, the capital of India, New Delhi. Delhi is also pronounced as Dilli in Hindi. Hence, it is not surprising to find both variants in an unclean text corpus. Similarly, surname Agrawal has various spelling and pronunciation, performing stemming and lemmatization to these words will not help us as much because the problem of redundant tokens will still be present. Hence, we need to reduce all variations of particular word to a common words. To achieve this, you will need to know about what is called phonetic hashing technique. Phonetic hashing bucket, all the similar phenomena in a single bucket gives all these variations, single hash code. The word Dilli, Dilhi will have same code. The coding is necessary, and that can be done by SoundX tools. How it can be done? Say, in this system, we tagged a number with an alphabet, such as B, F, P, V is 1. C, G, J, Q, S, X, K, Z, 2. D or T is 3. L is M. L equal to 4. M and N is 5. R equal to 6. H, W, Y is uncoded. This is one rule. Another rule, all vowel will be excluded for any word. Then, if we coding the if we coding a word Mississippi, MISSISSIPPI, to calculate the hash code, we'll make change to the same word in place as follows. 4-letter code basically. This is 4-letter code, Mississippi, the M122122111, Mississippi. If we change the spelling mistakes, if we mistake some spelling mistake also, this code is same for most of all spelling. First step is removal all the vowels. I is the only vowels. After removing all I's, we get the code M4211. Now you would need to merge all the consecutive duplicate numbers into a single unique number. All the 2 are merged into single 2, all the 1 are merged into single 1, then code is we get M21. The fourth step is to force the code to make it a 4-letter code. You either need to pad it with zeros in case it is less than the 4 character in the length, or you need to truncate it from the right side in case it is more than 4 character in length. Since the code is less than 4 character in length, we'll pad it with 10 at the end. Final code is M210. If we mistakenly spelled the Mississippi where 2S is missing, where 1P is missing, there is no problem. Final code will be M210 for most of all spelled of Mississippi. This is the interesting. Edit distance then. to handle the misspelling. Another is we learn how to make a spell corrector. All the misspelled word will be corrected to correct spelling. In other words, all the misspelled words will be canonicalized to base form, which is correct spelling of that word. But to really understand how a spell corrector works, you will need to understand the concept of edit distance. Now the question that comes to mind is, what's an edit? What is an edit? Edit operation can be one of the following. It's insertion of a letter in a source string, deletion of a letter from the source string, substitution of a letter in the source string. All that activity is done in Python through the different type of coding. To convert color to color, just insertion of U in between O and R. Mat to mat, insertion of deletion of T from the double T. Iran to Iraq, substitution of N, substitution of Q in place of N, basically. It is easy to tell the edit distance between two relatively small things. You can probably tell the number of edits that are needed in the string allowed to append. Did you guess how many? You need 3 edits. Substitution A to E first, upload to append. There is 3 edit. First A to E. Then you require 2 deletion. Later U and D. Hence you need a total 3 edit operation in this case. But this was a fairly simple example. It would become difficult when the 2 strings are relatively large and complex. Detail, rearrest, and deletion. It's the obvious and first look, and it's a very complicated edit distance theory. To use spell corrector, generally we use a spell corrector system, spell corrector library we use, and that you must finish building. You could import the spell corrector using the following command: from spell corrector import rectify and correct equal to rectify learn print. For spell corrector we use in brief we can say spell corrector we use the spell corrector library and import rectify, and then correcting the all misspelling words. Okay. And then very important, the point twice mutual information. This is the extraction of information. Point how can I explain this? Point twice in first I am talking on a simple sentence. I go to Calcutta. I is a go is a verb. Calcutta is a noun, and to is a preposition. And I exclude the to since it is a stop word. And I also, and go and Calcutta. And then go is a verb, and Calcutta is a noun. From the previous discussion, we analyze only the word and parts of speech of this word, root word or base word. That's all. We don't know still what is the difference, what is the relation between neighboring words. It is very important. Verb after noun or noun after verb. This is relation. We don't know when one word we don't know how to analyze the one word. Sometimes one word is used as verb, and sometimes that word is used as noun. This misnomer, how can I analyze it? We analyze this type of complications through the point mutual information. Till now, but there is another common scenario you will encounter while working with text. Suppose there is an article, higher technical education in India. Higher technical education in India, which talk about the state of Indian education system in engineering space. Let's say it contains names of various Indian colleges, such as International Institute of Information Technology, Bangalore, Indian Institute of Technology, Mumbai, National Institute of Technology, Kurukshetra, many other colleges. When you tokenize this document, all these college names will be broken into individual words: Indian Institute, International, National Technology, and so on. But you don't want this. You want an entire college name to be represented by one token. To solve this issue, you could either replace these college names by a single term. So, International Institute of Information and Technology, Bangalore, could be replaced by IITB. But this seems like a really manual process. To replace words in such manner, you would need to read the entire corpus and look for such term. It is very hectic. Turns out that there is a metric called point out mutual information called PMI. You can calculate PMI score of each of these terms. PMI scores of terms such as International Institute of Information Technology, Bangalore, will be much higher than the other terms. If the PMI score is more than the certain threshold, then you can choose to replace these terms with a single term such as International Institute of. Understand? The PMI calculation. Through the PMI calculation, we can concurrent. We can merge the group of words and treat as one word and tokenize it. How it calculated? The probability theory, log of and the PMI of such terms. The PMI is XY. The X is one word, Y is one word. The PMI is a log of PXY by PX and PY. And for three words, ZXY, ZYX by PZ, PY, and PX, and equal to Z. If we choose words as occurrence context, then the probability of word is PW. Number of time given word W appears in a text corpus by total number of words in a corpus. Similarly, if a sentence is the occurrence context, the probability of word is given by number of sentences that contain W by total number of sentences in the corpus. Similarly, then go to the syntactic processing. Syntactic processing, we now still now we discuss on the lexical processing, basically splitting the words, stop word removal, tokenization, and stemming, lemmatization, then bag of words, TF-IDF, and then cannibalization, etc. And then from the lexical operation, a lexical algorithm, we know specifically, we know the word of a sentence, frequency of word of a sentence, importance of word in the sentence. But still, we don't know the relation between the words in the sentence, relation between one word with another word in the sentence. So that's why many information already have been missed, will be missed in lexical operation. Then you need to another operation, syntactic operation. The information extraction. There is another information extraction algorithm. Syntactic processing is widely used in applications such as question answering system. That means it's understanding. Question answering system means it's understanding of the information, understanding of the data, total understanding of the data. Information extraction, sentiment analysis. Where it is required, sentiment analysis is required where customer centric business. For any customer centric business, the sentiment analysis is a very important. Grammar checking, etc. In this module, you learned that there is a 3 broad level of syntactic processing: POS tagging, and parts of speech tagging, constituency parsing, and dependency parsing. POS tag is a crucial task in syntactic processing and used as a pre-processing step in many NLP applications. Now, POS tagging, what is it? One sentence. Okay, Google, where can I get the permit to work in Australia? The word permit can potentially have 2 POS tags: noun or a verb. In this case, I need a work permit. The correct tag of permit is noun. On the other hand, in the phrase, please permit me to take the exam, the word permit is a verb. Same word. In one place it is noun, in another place it is verb. In same corpus. In different sentences, but in same corpus. Parts of speech are the groups or the classes of words that have similar grammatical properties and play similar roles in a sentence. They are defined based on how they related to neighboring words. It is very important. This is the syntax in syntactic processing. This relation is very important. We know the relation between 2 words in this algorithm, in this thought process, syntactic processing. There, assigning the correct POS tags helps us better understand the intended meaning of phrase or sentence, is thus a crucial part of syntactic processing. In fact, all the subsequent parsing techniques used the parts of speech tags to parse the sentence. POS tags can be classified in 2 ways: open class and closed class. Open class and closed. Open class refers to tags that are evolving over time, and where new words are being added for the POS tag, such as permit in some time, noun, permit is sometime verb. That is, it is an open tag, with the time, over the time, it is evolving. By adding the many verb in noun class or verb class. Noun, verb, adjective, adverb, interjection. Some useful example of open class POS tags are as follows. Name the name of the person, words that can be added or taken from another language, such as words taken from the Sanskrit language, such as yoga or karma words that are noun, but can be used as verbs, such as Google words that are formed by a combination of 2 words, such as a football, full moon, washing machine. Closed class refers to tags are fixed and do not change with time. That is closed class. Example is a preposition, pronouns, conjunction, article, or a closed class. A, N, U, I, the close. And in this case, in this syntactic processing, we use the Spacey library, open source library, used for advanced NLP processing and similar to NLTK, which you have used in lexical processing. Lexical, in case of lexical, we use the NLTK library, and in the syntactic, we use the Spacey library. Just one example, Tagger input, she sails on the seashore. Tagger output, she pronoun, sails, verbs, she sails noun, on conjunction, the it just article basically, seashore noun. Now we use the hidden Markov model for tagging POS. In previous previous segments, you learned about the POS tagging based on the frequency of tags alone, which seems inefficient when words are used in different contexts. So to improve this model, in this segment, we will learn about the hidden Markov model, which performs better and uses the context of previous word to decide POS of the current word. Let's consider the following example. What does your mind process when you see the blank space at the end of the sentence? Rahul is driving to dash. Don't you think the blank space should be the place of name of place? How do you manage to identify the blank space would be the name of place? Try to analyze our thoughts after reading this statement. When you see the word Rahul, who is driving to some place, and hence you reach to the conclusion that the blank space should be the name of the place. This means you have sequentially looked at the entire sentence and concluded that the blank space should be the name of the place. That is called sequence leveling. This is called sequence leveling. What is sequence? The Rahul, the noun, and the beaver is, and is also a stop word, not to count it. Driving is a noun verb, and to is a stop word. Just exclude it. The noun, Rahul, noun, and then verb, noun, verb, maybe noun. What will be the more probable? NVN. That is another logic for the hidden Markov. Why it is hidden? It is very important. Why it is hidden? It is hidden when we see a sentence. We just observe. First, we observe the word. We directly not observe the parts of speech. It is our hidden observation. It is our hidden observation. We observe mainly word. We first extract the information from the word, but our hidden observation is POS, parts of speech. That's why that model is arise. The hidden Markov model. So try to analyze your thoughts about the reading the statement. When you see the word Rahul, who is driving to place, and you reach the conclusion that the blank space should be the name of the place. Also, hidden Markov model can be used to sequence leveling, which means it takes input of words in a sequence and assign the POS tags to each word based on the POS tag of previous words. Then, who won the FIFA World Cup in the 2014? The QA system, question answering system, such as can respond it meaningfully only if it understand the phrase FIFA World Cup is related to the phrase in 2014. The phrase in the 2014 refers to a specific time frame and thus modifies the question significantly. Finding such dependencies or relation between the phrases of a sentence can be achieved using parsing techniques. Let's take another example sentence to understand how the parsed sentence look like. The quick brown fox jumps over the table. The structure divides the sentence into in the following three main constituents: the quick brown fox, which is a noun phrase, jumps, which is a verb phrase, over the table, which is a prepositional phrase. It's a parsing technique. It's a parsing technique. What is parsing technique now? Parsing techniques. Before, still now, we learn the word tagging, word encoding. Then we learn the word tagging with POS. Then we learn word relation between words through using POS. And then now we learn the parsing. We learn parsing, tagging, to understand the complex grammatical structures and ambiguities in a sentence that most human language consists of. A key task is the syntactic processing is parsing. It is very important. It means to break down a given sentence into its grammatical constituents, not into the words, the grammatical constituents. Phrase is one of the grammar, idioms, phrase, group verbs. Group verbs is a number of words, comprises of a number of words. Break through is a group verb. Break throat is a group verb. Break is word, forth is another word. But when we join the both word, break and forth, meaning of this break forth is different from the break and forth. That's why grammatical complications can be solved by the parsing techniques. And the parsing techniques are very important to analyze the important information from the document. Parsing is an important step in many applications that helps us better understand the linguistic structure of sentences. You need to learn techniques that can help you understand the grammatical structure of complex sentences. Constituency parsing and dependency parsing can help you achieve two type of parsing: constituency parsing and dependency parsing. Constituency parsing is meaning what is the constituency parsing? Basically, constituency parsing is the constituent related to the constituent of the sentences. Constituent of the sentences. The quick brown fox jumps over the table. Quick brown fox is a noun phrase. Jumps over the table is a verb phrase. Over the table, sorry, a prepositional phrase. Quick brown fox, the noun phrase, jumps the verb phrase. The noun phrase, VP, verb phrase, and preposition PP, the preposition phrase. Constituent parsing is the process of identifying the constituent in a sentence, a relation between them. And then dependency parsing. It is a very easy. Dependency parsing is a dependent constituent. We discuss the constituent parsing where groups of words are constituent from the basic structure of parse tree. In this segment, we will introduce an alternate paradigm of the grammar called dependency grammar, related dependency parsing techniques. Dependency parsing, we do not form constituencies, but rather establish a dependency between words themselves. Dependency parsing identifies relation between words and produce a concise representation of these dependencies. This is one kind of relation between two segments, between two phrases, not a word only, between two phrases also. Now, I want to show one Full example. Mhm. One example, it is on the ticket collection classification. Data classification to we get different type of comments on a financial company customer comments, and we segregate according to their query. What type of pattern, what type of classification of tickets? Tickets means issues, credit card related, bank account service related, dispute reporting, mortgage, loans, and others. That type of different type of issues, 5 clusters there is for in a financial company. Our aim to analyze their comment and classify into the 5 classes. First, loading the data first. Data set, loading the data set. It is taken from the Kaggle or GitHub. The Kaggle and GitHub is the main source of our data set for practicing. And Kaggle and GitHub, we must sign in this Kaggle and GitHub, and you can get many new information from GitHub mainly and Kaggle also on this subject, on this AI system. So just import JSON and import NumPy NP, import pandas PD, import re means NLTK system, NLTK specie string, ncore web SN, and Seaborn SN for plotting, Seaborn and SNS plotting, matplotlib, pyplot, APLT, and SKPJ instruction, TF-IDF vectorizer for TF-IDF calculation. And then why we need TF-IDF calculation? We need to understand the importance of the words in a document. That's why we want to know. We need to know the TF-IDF value. Okay. First, data preparation. This data, DF source tag, jeep number, complaint, source issue, data received, source data, various column and column number of columns, DF columns equal to index type ID score. Not more important for all column and complaints. What happens? No complaint has been found in this system. That's a DOPNA. This is excluded from this data set, and that is pre-process. Then we have done. We need to make a data set where we found complaint what happened and lemmatized complaint. Mainly complaint what happened. Complaint, we need complaint and leveling. 1, 2, 3, 4 leveling. We need this column only for this NLP program. Then that complaint, clean the data frame, contains raw complaint, lemmatized complaint, and complaint the removing POS tags. After removing POS tags, and show up, you share
Yes.
all the coding
We'll do
module
that.
with the learner. We'll share all the here. This another word, 30 unigram frequency among the complaints in the cleaned data frame. Clean data frame, which word will be important? Chase, account, credit card, chase 50,000 on 5 times, account 47,000, credit 30. How many times? Unigram frequency, and then bigram frequency. Bigram means 2 word. How many times it will be found? Credit card, credit report 12,000. More is found. A credit card is a more frequent complaining, asking system. Credit card, chase credit cards, credit card account, credit card company. Pre-process, all the pre-process, all the cleaning, the lemmatize and POS tagging and complaint clean. Then TF-IDF, we use the TF-IDF vectorize, maximum rate 0.95, minimum TF2, stop word equal to English, removing stop word, and TF-IDF fit transform and complaint clean. And then we create a model for topic. This is I want to end this workshop now. I try the fundamentals of NLP algorithm, NLP system in 2 hours. It is very, very short for this course. If anyone will be interested, again, and just mail to the SRF. And we will arrange another workshop for this course. Thank you, everyone. Welcome.